How's it going, everyone? In the previous video, we created our very first AI agent in Python, and it looked like this. It gave us a prompt which allowed us to insert some text, such as tell me a funny programming joke. It would then think and give us a response. Why do Java programmers prefer dark rooms? Because null pointers look better in the shadows. Alternatively, here's a classic one about the difference between languages. There are only two hard things in computer science: cache invalidation, naming things, and off by one errors. So as you can see, we were able to use this AI agent directly in Python. And this is something you can connect to other applications if you want this kind of AI agent in your programs. Now, in this video, we're going to learn how we can supercharge our agent by adding dynamic context injection. And what do I mean by context? Well, things like the current date and time, the current user, file contents, or any other information that changes over time. With our basic agent, this information would be stale after the first request. Now we'll make it dynamic, because right now, if we were to type in what time is it, the assistant would be unable to give us the current time, because it does not have any context regarding who we are, where we are, or what time it is. So the key insight is that we want to provide fresh information to the agent on every single request, not just at the beginning. We'll use a decorator pattern to register context functions that get called right before we send each message to the LLM. And before we dive in, I just want to thank Zed for sponsoring this video. Zed is a lightning-fast code editor written in Rust, and I've been using it for all my coding lately. If you want to follow along with the same editor I'm using, check the download link in the description below. Otherwise, let's get started. For this video, I'm just going to write all the code once again from scratch. But if you followed the previous video, you don't have to do this. You can just add the updated code to your current code. So to get started, I'm going to import requests. From typing, I'm going to import callable. From data classes, I'm going to import the data class and the field. And once again, from typing, I will import any. And for those of you who are crazy about reducing code, you can add any to the typing section. Next, we're going to create a data class called agent. And this time, instead of using LLM Studio to provide a prompt, we're going to provide it right here. So here we have a system prompt that says you are a helpful assistant. In the previous video, I wrote write everything in Italian. So here you can add whatever context you want. Then we need to specify the model which we are using, which in this case will be Qwen 3.5. The base URL will be set to the local host that we were using in the previous video. And since we are using a local API, we will not need an API key. So the default will be set to no API key. Below, we're going to add some context. And this will be of type dictionary, which contains a key of type string and a value which will be of type callable. And here we will create a new field which will contain an empty dictionary. Then for the conversation history, we will create some messages, which will be of type list and contain a dictionary of type string to any. And once again, we will create a new empty list. And just as in the previous video, we're going to remove the trailing slash from the base URL by creating a post initializer block and stripping the backslash. Now down below, we're going to create a context decorator. The context decorator lets us register functions that will be called to generate context. We use the function name as the key, so choose descriptive names. These functions take no arguments and return a string with the context information. So right below, we're going to type in that the self.contexts at the function .name is equal to the function. And then we will return the function. And all of these functions take no arguments and return a string. That's what this type annotation tells us. Next, let's update the chat method. The key difference here is that before sending messages to the LLM, we will call all our context functions and format them as XML style context blocks. Then we prepend these to every request as system messages. So once again, we need to add the user's message to the history. Then we need to create the context content, which will generate fresh context by calling all registered context functions. So here we have two new lines, followed by join. Then here we join the context for all the context items. Then down below, we're going to create a prefix. And this will prepend context as system messages. And down below, we make the API call with the context included. So once again, let's create that URL and provide the headers. Then we want to create the request, which this time will contain the prefix plus the self.messages. We will raise for status in case there are any errors, try to grab the JSON back from the request, and then try to grab the choices. So everything that we did in the previous video. If there are no choices, we're going to raise a runtime error that the model response is missing choices. Otherwise, we can retrieve the message. Now, if the message is none, we're going to raise a runtime error once again, telling us that the model response is missing a message. Otherwise, we're going to grab the response, which will either get the content or return an empty string. And finally, we will append the response to the messages. And the final step is returning the response. And with those 60 lines of code, we can create our if name is equal to main check and the main entry point. Now, before we continue, we do need to take care of a few imports. For example, we need to import console from rich.console, we need to import datetime, and we need to import getPass. Next, we can create the agent, which will be set to Qwen 3.5, and we can provide a system prompt. Here I just told the agent to end every message with a yo mama joke. Then down below, we're going to register a context function that returns the current time and user. So using the context decorator, we can decorate this function, which returns the current date and time and the current user. And all we're doing here is providing this information. We use datetime to get the current date and time, and we format it. Then we use getPass to get the current user on our computer. Then to format things nicely, we're going to create a console, which we imported from Rich. And before we create an infinite loop where we can type code, we're going to create a with block, which contains the console status, and that just creates a spinner while we are waiting for a response from the agent. And the first message is going to be what time is it and who am I? And just to show you what this outputs, we're going to print what we wrote, hypothetically, and the response. Now, if we were to run this, the agent will think, and as soon as it's done thinking, it's going to give us the current time, the current date, and who I am, plus the yo mama joke. Yo mama's so old, she knew share before the C word was cool. And I have no idea what that means, but I'm happy it attempted to make a yo mama joke, following the prompt that I gave it. But let me explain why this approach is so powerful. Traditional chatbots get the system prompt once at the beginning, and that's it. With our approach, every single request includes fresh context. Think about it this way. If you ask the agent what time is it in the morning, then ask again in the evening, it will give you different answers because the context is regenerated each time. Another benefit is that the context functions are just regular Python functions. This means you can read files and include their contents, query databases, call APIs to get external data, access environment variables, and do anything else you can do with Python. My recommendation is to keep context functions focused and return only what's needed. Too much context can overwhelm the model. So now let's see how the context is truly dynamic. So once again, I'm going to create an agent, this time leaving out the yo mama jokes, and the system prompt will say you are a helpful assistant that always mentions the current hour. Then right below, we're going to create some context, which grabs the current date and time, and which injects the current hour into the context. And right below, we're going to generate the first response by asking the agent, what hour is it? Then below that, we're going to make a second request, which is going to regenerate the context. This time, we will ask the agent to tell us the hour again. And here, we will print the response a second time. So right now, if we were to run this, the bot has to think, it will give us the current hour, then it will make a second request and give us the hour once again. But let's go back to the baseline where we have the agent. And once again, we're going to create some context, which grabs the current date and time and the current user. Here, we're going to change the prompt to you are a helpful assistant that highlights the current time. And right below that, we're going to create the console once again and create a while true loop to create a program which continuously asks for user input. Here we ask for the user input, then check whether the user wants to exit. And if the user doesn't want to exit, we continue with grabbing the response from the agent. And then the agent returns the response or prints the response. So now, with only 90 lines of code, we have an AI agent that can use dynamic context, which is awesome. Hello there. Hello, Federico. It's currently April 15th, 2026 at 8:57 a.m. How can I help you? Tell me a good programming joke. And just like that, it's able to use the context from my system. Why do programmers prefer dark mode? Because light attracts bugs. And then to end the chat, all you need to do is type in exit or quit. And again, you can always grab the current time using the context you provided. What time is it in an hour? It is currently 9:58 a.m. or 9:58 on Wednesday, April 15th, 2026. That's not the current time, you silly goose. The current time is 9 a.m. or 9 on Wednesday, April 15th, 2026. I calculated the time and hour from your previous query instead of just telling you the current time. Thanks for catching that. So now we're back to the apologetic AI that we've all been using online. So yeah, just like with any AI, you still need to adjust the prompts so that the AI agent can return appropriate responses. As you saw right here, it didn't really understand what I was asking, or it understood what I was asking, but it wasn't able to generate a response that made sense. It calculated the time 1 hour from now, but it said that it was currently that time. There's still one major limitation. The AI agent can only respond with text. It can't take actions in the world. It can't do math, read files, send emails, or do anything that requires more than just generating text. So that's what we're going to be covering in the next video. But until then, I'd love to hear your thoughts on this AI chatbot in the comment section down below. Let me know if you'd like me to explain something in further detail, or whether you have any recommendations on how to improve it. But otherwise, with all that being said, as always, thanks for watching, and I'll see you in the next video.